Hey y'all, Data Guy here. And today I have a video for you where I'm going to show you how you can use PySpark and the PageRank algorithm by Google to determine the relationship of one URL to a set of other URLs. So PageRank, this is an algorithm that was developed by Google Search to rank web pages in their search engine results. So essentially what we're doing here is mimicking Google and saying, hey, if I'm searching for this topic, what are the URLs that are the most relevant things to surface to me, and determine the relationship between, hey, what is the primary URL and then all these other URLs, and rank them in terms of their actual relevance to whatever the basic search query is. So going to show you how you can do that today. Going to show you a couple different ways you can kind of optimize and tweak the script for doing things like personalization. If you want to say, hey, personalize these recommendations for a given user profile. So a lot of cool stuff to show you today, and without further ado, let's get into it. So what we're going to do to get started is create a new PySpark script and PageRank spark.py, and then we can start building our Spark script. And so something might, if you're asking, hey, how do I actually run my own Spark script? How do I set this up myself? What you're going to want to do is go to one of my previous videos where I do break down exactly how to set up and run Spark locally. But assuming you've already seen that, I'm going to import some different libraries here. So first we have RE, which is just a library for regular expression operations. We also have sys here for just giving access to some variables that are used or maintained by our interpreter here, which is just the code interpreter. And then add, which is a function from the operator model used for summing up contributions. And then we also have iterable and tuple just for different types of data to use here within the typing module for type hints. And then we also have within from PySpark, we're pulling out the result iterable. And this is a special iteral that's used in PySpark for holding the results. And then Spark Session, as you know, this is just the entry point to programming Spark using PySpark and the data frame API. So now we've got all of our packages all set up. We can start building our Spark script. So now we've got our libraries. Our first function is going to be compute contribs. And so what this is going to do is compute the contribution of a given URL to the ranks of the URLs it links to. And so the rank contribution is evenly distributed amongst all the URLs it points to. And what this is referring to is, let's say you have a news article that's linking out to several other, several other web pages URLs. What this is going to do is calculate the URL contributions. So how much did that first page that linked to all those other URLs actually affect the ranking of those URLs within Google search ranking? Then we also, so that's just defining that function. You can kind of see here yielding. So we're using the PySpark yield function here to essentially just assign an equal rank to all the URLs referenced in our first base URL. And so you can see just rank over number of URLs and then URL here. Then our next function is going to be parsing a line of text. So this is how we're actually going to generate these URLs into a pair of URLs. So this is a URL pair string, so two neighbors, so two URLs that are maybe appended together, or a sub URL. What this is going to do is parse that pair string into URLs pair. So you can see here, and this is just splitting, when there's a separation between URLs here. Then what we'll do is define our main execution block. And so this is basically just going to be kind of the framework for our script, making sure that our script is run with the correct arguments, which is going to be an input file. So an HTML file that's going to represent a URL and all the URLs that are linked to within that web page, and the number of iterations that you want to have in here. So here, name equals main, and then what this is just doing, length, sysargument doesn't equals 5, and this is just saying the usage, PageRank, file, iterations, and the file is just reading the system message, whatever file you're inserting into this script, and checking that it is the proper length, that it's not equal to 3. So after we verified our inputs are correct, the next thing we'll do is just initialize our Spark sessions. So here, Python PageRank, get or create if one already exists. And then after that, we are actually going to do some data loading. So first thing we're going to do, so here is read a text file, so just aligned here, but read a text file into a relational database, and extracting each line within that text file. So taking it from just wall of text to lines that we can iterate through to pull out those URLs and then rank them. And then links is transforming each line into a pair of URLs. That's how we're getting this pair that we're going to split later, where essentially what's happening here is each line is being transformed by using parse neighbors, so turning the splits URL pairs, and then removing any duplicates, grouping by the originating URL, and then caching the result for performance. So caching the grouped URLs in kind of local memory storage so we can access them easier later down. Then what we're going to do is actually initialize our ranks. So we're going to start with every URL is going to just be given a rank of 1.0 for now, just as a starting point. And then what we'll do is use the PageRank computation loop to actually iterate through all of our different URLs and assign them a rank. So here for iteration in range, and then sys arguments, so making sure just the range of sys arguments that we're using. And again, that sys arg is just referring to our input file here. But then what we're going to do here is join links with ranks to compute the contributions for each URL. So joining that rank array we created for our different URLs, joining that to the actual URL. So that link of one, so now all of our URLs start with a rank link of 1.0. And then so after we join that, we'll then be able to compute contributions. So flat map, just joining 1-to-1. And then our ranks, what we're doing here is summing our contributions using reduce by key and then recalculating ranks with a damping factor. So 85% of your accumulated score plus a base score of 15. So basically saying, hey, this is your rank by, so this is where the PageRank algorithm is coming into play. So that's why you're not doing all the computation here. But what this is doing is basically using the PageRank algorithm to say, hey, what was the actual. Also, something to note that I guess I hadn't before is that this is what kind of the format of this file looks like. So the input file is just URL and neighbor URL. So joining, hey, URL relational to another URL that it links to. So that's why we had to do that splitting of the data here, because we have two URLs in each line entry. So here, iteration range, and then using our contributors, computing for the different rank of each of the URLs. And then what we'll do is we're just adding them, applying a weight of 0.85 just so it doesn't fully dictate it, and then they all have kind of a base rank of 0.15. So after we're done with that, then what's going to happen, and actually I think this is a better way of visualizing it. So here, yeah. So here you can see kind of just it's all one line. Actually, it just kind of gets broken out like that when I copy and paste it wrong. And then here, ranks down here as well. So it just makes it a little bit clearer for you to see. And then what we're going to do is just collecting all those URL ranks and dumping them into our console. So here for link, rank, and then printing, just it's going, here it's going to take the first value, our link, so your link, and then inject the second value, rank. You can see that aligned there using that Jinja templating. And then after we're all done, we just can run our Spark stop command. So that is the basics. Now, this is just kind of a very basic, naive implementation of PageRank, so just kind of an example. And you can see that here. And actually, let me make sure that this is set up properly. Yeah, we're all good. So what I also wanted to show you is how you can define ranks based on a personalization vector. So essentially, personalization vector, in adding that to the PageRank computation in PySpark, allows you to customize the importance of nodes in the graph. So if you want to bias ranks towards specific types of pages or areas of interest, like saying, hey, all URLs that are from Amazon, they get a big buff because Amazon paid us $50, right? And this is just using Google as an example there. So I want to show you how you can modify the script to include a personalization vector. And so the first thing you're going to need to do is just create a personalization vector. And so what that looks like is just something like this, where we create a vector of personalization and assign these links different weights. So higher the weight, higher the importance. And this is how you can bias just those raw PageRank search result or PageRank results to actually say, hey, bias towards recommending these pages if you want to tweak that. So then how we'll actually initialize those ranks based on the personalization vector is we'll define a function called initial rank. So here, what we can do is define initial rank, and if URL in personalization, return the personalization URL, and then otherwise just return 1.0 links. And so what this is going to do is will give us the weighting result of 0.1, 0.2. Otherwise, it'll just give us the default value. So in this case, just dividing 1.0 by the total amount of links or whatever default value you want to use. Then after that, we'll define our ranks links map. So here, similarly to what we did before, we just have that kind of ranks links map URL neighbors. Difference here is we inject that initial rank function, so we can inject those weightings when we're creating the weight. And then the personalized rank down here, so defining a personalized rank with the dampening factor will look something like this. So instead of having this simple ranks equals contributes reduced by key, what you would have is this personalized rank set up here. So personalized rank, contributions, total contribution, personalization vector. And then what we're doing is we're multiplying that 0.85 times total contribution plus the personalization vector, so getting whatever that weighting is and assigning it to our rank. So you can, again, this is how you're going to be able to tweak the PageRank weighting. And then for iteration to kind of putting it all together, PageRank iterations, so after personalized rank, for iteration and range, so again, just injecting that file, joining those links, flat map, and then just linking the contributions to each rank, so linking URL to each rank based on their contribution, so how much they influence that URL. And yeah, all we're doing is just adding that additional value here. So instead of just a single, so compute contribs, it's not just based off that initial rank, it's based off the rank plus our weighting times our weighting. And yeah, just wanted to show you, I found the PageRank algorithm and some examples. Makes it really, so this RDD that we're using here, this is actually just going to be part of the initial PySpark relational database. So you don't need to have a separate database set up. This just uses a built-in database in your Spark session. So kind of wanted this as both example of how to use the PageRank, also using the example database, and just kind of defining more complex workflows with PySpark. So I hope you found this useful. I hope you found it enjoyable, and I hope you have a great rest of your day. Data Guy out.